Okay, today we discuss the properties of covalent compounds. All in the class 1, we discussed some of the properties. So the remaining properties will be discussed now. Okay, already we discussed about melting point, boiling point. Just I will revise that properties fastly. Okay, so the first one, melting point, boiling point. So the melting point, boiling point of covalent compounds are very low because due to the very weak van der Waals forces of attraction, it requires less energy to break them. Less energy means it requires less temperature. So therefore, their melting point, boiling points values are generally low. But exceptional cases, some covalent crystals are there. That is diamond, graphite, silicon carbide, that is carborundum, next silica. So some are having very high melting points. Okay. Next, the second property, that is physical state. So due to the low molecular masses and weak van der Waals forces of attraction, they present in gaseous state, or some of them are in liquid state having low boiling point. So this is happening only due to the weak van der Waals attractions. Due to the weak van der Waals attractions, the molecules are not very close. So that's why they exist in the form of gases or liquids which are having low boiling points. But exceptionally, some are having solids. So solids which are having network type of, that is called giant molecules. Network type of means three-dimensional polymeric structures, that is possessed by diamond, graphite, silicon carbide, again silica, like that. Only they are present in solid state, that is very hard solids. And even there is some soft solids are there, that is iodine, argon. So these are soft solids. Even sulfur is a soft covalent solid. But maximum they are in gaseous state and liquids with low boiling points. Next we discussed about crystal structures. Okay, so all are gases, there is no crystalline structure for gases and liquids, but few of them are solids. In solids, we made into three types. The first type is having molecule is the one unit for the crystal. They are known as covalent crystals, or nothing but molecular crystals. Okay, in which molecule is the basic unit. For example, ionic crystals, ion is the basic unit. Same in the molecular crystals, molecule is the basic crystal, basic unit. Okay, one unit is one molecule. So next, second step, which are having layered structure just like graphite, which are very soft due to the movement. One layer can slide on another layer. So next one, three-dimensional polymeric form. They are very hard, that is diamond, next boron nitride, aluminum nitride, etc. So now we see the remaining properties. So that is the fourth one, electrical conductivity. Okay. So electrical conductivity. So generally covalent compounds are bad conductors. So on generalization, to final ga cheppalante, they are non-conductors. Generally covalent compounds they are bad conductors. They are bad conductors of electricity. Because in the formation of covalent bond, what happens? The bonded electrons are shared by both atoms. So both atoms shared that provided electrons. Therefore, there is no free electrons are present which can be used as a medium for passing of current or electricity. So for example, if you take ionic compounds in molten state, for example aqueous NaCl, molten NaCl, they are very perfect conductors, they are good conductors because there is a free ions are present in it. Na plus ions, Cl minus ions, they are free ions are present in the solution state, liquid state. So due to that movement of ions, current flows from one place to another place. Means for the movement of electricity or current, there must be one medium is required. ఏదో ఒక మీడియం ఉండాలి. సో జనరల్గా మనకి ఐనిక్ కాంపౌండ్స్లో అయాన్స్ ఆర్ ద మీడియం. ఫర్ ఎగ్జాంపుల్ మెటల్స్ తీసుకుందాం, కాపర్, సిల్వర్, గోల్డ్, ఇవన్నీ గుడ్ కండక్టర్స్. సో దాంట్లో ఏమవుతుంది, మూమెంట్ ఆఫ్ ఎలక్ట్రాన్స్ చాయిస్ ఉంటుంది. ఓకే, బట్ ఇన్ కోవలెంట్ కాంపౌండ్స్ జనరల్లీ దెర్ ఈజ్ no free electrons and there is no charged particles. So ionic compounds laga charged particles levu. Next, free electrons levu. The electrons are bonded tightly between two atoms. So they are bad conductors of electricity. Why? Because due to the absence of free electrons and any free charged particles. Means simply we can say there is no free electrons, there is no free charged particles, that's why they do not pass electricity through them. But in very rare cases, in some cases, but polar solvents, the polar covalent compounds, so like HCl, means polar covalent compounds means the covalent compounds in which the bond is present between the atoms which are differ in their electronegativities in very large value. Okay, and hydrogen electronegativity, chlorine electronegativity is very large. That's why it is treated as polar covalent molecule. Okay, for example, if you take H2, two hydrogen are connected, both are having same electronegativity, that is treated as a non-polar. Okay, means the polar solvent, the polar compounds, covalent compounds like HCl generally dissolves in, they can conduct electricity. Polar means there is a possibility of formation of H plus and Cl minus in presence of any solvent. అంటే సొల్యూషన్లో కన్వర్ట్ చేసినప్పుడు ఏదైనా ఒక సాల్వెంట్లో యాడ్ చేసి సొల్యూషన్ లాగా ఫామ్ అయినప్పుడు, సో there is a possibility of working of these covalent compounds like conductors. Okay, but the polar covalent compounds like HCl works as conductors. In their solutions. Okay, direct కాకుండా solution form లో they can conduct the electricity. But again, we do the some molecules, some exceptional compounds and covalent compounds. You know that the exceptional compounds in covalent compounds, what are that? We discussed at every point of these properties, that is diamond, okay, graphite, nitrides, okay, like that. Means giant polymeric. Covalent solids. Sorry. Covalent solids. Here, except graphite. Graphite is exceptional when compared to the other one, diamond. So, like diamond, all other examples. Okay, just we are writing the only exceptional one. The covalent solids except graphite are non-conductors. So then what about this graphite? What about this graphite? So this graphite. So the covalent solids except to graphite are non-conductors. Means diamond, boron, nitrates, all are non-conductors. So gentlemen, diamond ki graphite ke we see some comparisons. Okay, write them. Okay, here you see the diamond. Diamond is a non-conductor. So why it is a non-conductor means due to the absence of same free electrons. But whereas it's another form, that is graphite. So why we are comparing only diamond and graphite? Means both are carbon compounds, exactly carbon compounds. Or diamond consists of all only carbon atoms. Graphite is also having only carbon atoms, but the structural are different. So it is a polymeric giant molecular structure. You know the polymeric giant molecular structure. That's why very hard. But it is having layered structure. Yesterday we discussed about this. Graphite is a layered structure. So layered structure kabatti it is smooth. In the same way, there is no free electrons in diamond. That's why it is a non-conductor. But in graphite, free electrons moves from layer to layer. So that's why graphite works as a good conductor. Okay, it is not only this conductor, it works as a very good conductor. Very good conductor. Graphite is very good conductor. So that's why it is used in many electronic devices. Okay, many electrical and electronic devices it is used. For example, the remote batteries. The inside black color rod is made up of graphite. Okay. So this was about the property, that is electrical conductivity. Okay, so next we see the next property. So that is okay, solubility. Solubility means dissolving. Okay, so already we know ionic compounds dissolves in polar solvents. Polar means which are having positive pole and negative pole. So means polar ionic compounds. Ionic compounds are nothing but treated as polar compounds. Polar compounds dissolves in polar solvents in the same way. So the covalent compounds are generally non-polar. They dissolve in non-polar solvents. Okay, means so always the solubility follows one rule, that is likes like means like dissolves in like. Okay, any compound follow this like dissolves like, means polar compound dissolves in polar solvents, non-polar compound dissolves in non-polar solvents. Generally covalent compounds are treated as non-polar compounds. So therefore we can write covalent compounds dissolves in non-polar solvents. Non-polar solvents, we need to know examples. So like non-polar solvents means like carbon disulfide, okay, benzene, like carbon tetrachloride, chloroform, okay, ether, so etc. So this type of, so we need to remember this all time. These are generally non-polar solvents. Covalent compounds are generally treated as non-polar. Okay, covalent compound generally non-polar ga treat chestam. So non-polar. So same attractions untayi kabatti they dissolve easily in. But ikkada what about water? So water is a polar solvent. It is having H plus and OH minus, two positive pole and negative pole, both poles. That is called a polar solvent. So kabatti covalent compound generally does not dissolve in water. Okay, it is a general statement. Generally covalent compounds does not dissolve in water because water is a polar solvent. So why we are discussing about water separately? Why we are discussing about the water separately means, so generally covalent compounds does not dissolve in water because water is a polar solvent. But what is also we given a name for water, that is called a universal solvent. Means even some covalent compounds, even many covalent compound does not dissolve, but very few compounds are there. They are easily dissolved in water, even they are having covalent nature. Okay, but some covalent compounds but some covalent compounds dissolve in water. But how it is possible? So the examples are alcohols, and there is also amines, some acids, bases, etc. So even they are having a acids, bases. So not always. Okay, it depends on the acid or base. But alcohols always dissolves in water. Amines always dissolves in water. So how they dissolves in water? So dissolve avvadaniki akkada edo oka like thing undali. Okay, alli mana starting lo ippidam like dissolves like. Just like love loves love. Okay, same ఉన్న compounds interact అవుతాయి. So difference in the compounds interact అవ్వవు. But alcohol amines are covalent compounds, nothing but non-polar compounds. The water is a polar solvent. But how they are dissolving each other means the particular reason is there. So that is so because alcohols, amines, etc. form a special bond that is called hydrogen bond. So it will comes at the end of our chapter. Just remember that is hydrogen bond. Means alcohols and amines, some other compounds also forms hydrogen bonds with water. So therefore they dissolve in water easily. Okay. For example, take an alcohol, that is CH3CH2OH. It is an alcohol. Next, water. Water means here H2O. So when we combine this alcohol in water, there is some attraction takes place between this alcohol and water molecules. Okay, so like this, due to this interaction forces, so generally these are known as hydrogen bonds. So due to this type of bond formation, alcohols and amines dissolve in water easily. Okay. Next, the important point here, the covalent solids. So just now we discussed about the covalent compounds. Mainly we discussed about the liquids. Okay, these alcohols, amines, acids, bases all generally form in liquid state. Okay, but here covalent solids. So what are covalent solids? We know the exceptional cases, that is diamond, graphite, boron nitride, aluminum nitride, silica, carborundum. They not at all dissolve in water. Okay, covalent solids. So not at all dissolve in water. For example, if you take diamond, so diamond does not at all dissolves in water. Even it does not dissolve in non-polar solvents like petrol, diesel, ether, chloroform, carbon tetrachloride. If you take the graphite looks very soft. Okay. Now when you just say pencils, okay, the pencil refill inside the pencil is made up of graphite. That is a very soft, but not at all dissolves in even kerosene, some oils, and even in water. Means simply we can say covalent solids does not dissolve in any solvents. Not at all dissolves in any solvents. Okay. So what are the examples covalent solids means? So generally they are okay. They not at all dissolve in polar solvents and also non-polar solvents. Okay. So this is about solubility. It's an important one. Okay, next we see the other property. So there is molecular reactions. Molecular reactions. So molecular reactions. So the molecular reactions mean generally the covalent compound reactions are known as molecular reactions. So the reactivity of covalent compounds is very slow. Okay. Reactivity of covalent compounds. Covalent compounds is very less. So when you compare the ionic compounds reactions, they are very quickly spontaneous reaction takes place. But here they are very slow reactions. So why they are very slow reactions means in these reactions so at first bond breaking, then bond forming takes place. Means if a covalent reaction should happen, there must be the breaking of old bonds and forming of new bonds should take place. Means in these reactions bond breaking, then bond formation takes place. It is compulsory. Which requires large energy. Which requires a lot of energy. Okay, so therefore these reactions, very slow reactions. Okay, reactions starting up, the reactions are not able to complete 100%. If you take ionic reaction, they are very fast. They lead to 100% completion. But the covalent reactions takes place very slowly, and the 100% reaction does not takes place. Means so due to the bond breaking and bond making takes place, which requires lot of energy. That's why the reactions are very slow. So therefore, these reactions does not complete does not leads to completion. Totally complete ever possible ever. So here with the help of example, for example, hydrogen Cl2 forming 2HCl. Okay, now we explain this. H2 means H bond H. Cl2 means Cl bond Cl. HCl means H bond Cl. So like that, two are present. Means at initially which bonds are present? Initially in H2 means ఇంకా మనం H2Cl2 add చేయలేదు. We are not at all added the H2 and Cl2. But only if you take H2, H bond H separate. In Cl2, Cl bond Cl separated. If ఈ రెండు యాడ్ చేస్తే మనకి ఏం ఫామ్ అవ్వాలి? HCl ఫామ్ అవ్వాలి. అంటే H and Cl ఫామ్ అవ్వాలంటే at first the bond present between them must be break down. So ఇది బ్రేక్ అవ్వాలి, so ఇది బ్రేక్ అవ్వాలి. Okay, so after this breaking of this bond, two separate hydrogens are formed, two separate chlorines are formed with their electrons. So next, there is a formation, means now the breaking of bonds takes place. Bond breaking takes place. Then bond formation should takes place. Again, this H should combine with this Cl, forming one HCl. This hydrogen should combine with another Cl, forming HCl. And here breaking takes place and forming takes place. But in ionic reactions like the only plus minus. అక్కడ ఎలక్ట్రాన్ షేరింగ్ లేదు, బ్రేకింగ్ అవసరం లేదు, జస్ట్ అట్రాక్షన్ ఉంది కాబట్టి ట్రాన్స్ఫర్ ఆఫ్ అయాన్స్ సరిపోయింది. బట్ హియర్ దే ఆర్ షేర్డ్ ఎలక్ట్రాన్స్ కాబట్టి ఎట్ ఫస్ట్ ఎట్ స్టార్టింగ్ ద రియాక్షన్ స్టార్ట్స్ ఓన్లీ వెన్ bond breakage is started. So after bond breaking, then there is a formation of bond making takes place. So for all this process, it requires lot of energy. That's why they are slow reaction and does not leads to completion. Okay, so this is about the reactivity of covalent compounds. Okay, write down. Okay, see the last one, that is isomerism. So isomerism, so actually in ionic compounds, we simply said ionic compounds does not show isomerism. So we did not give any definition for it. But covalent compounds, covalent bonds are generally directional bonds. అంటే ఏ డైరెక్షన్లో ఎలక్ట్రాన్స్ షేర్ చేసుకుంటాయో సో అదే డైరెక్షన్లో ఎలక్ట్రాన్స్ అదే డైరెక్షన్లో బాండ్స్ ఫామ్ అవుతాయి. మీన్ ద డైరెక్షన్ ఆఫ్ కోవలెంట్ బాండ్ ఈస్ ద డైరెక్షన్ ఆఫ్ షేరింగ్ ఆఫ్ ఎలక్ట్రాన్స్. Means covalent bonds are directional. Therefore, they can exhibit isomerism. Okay. They exhibit isomerism as the covalent bond is a directional bond. So now we define what is isomerism. Okay, so isomerism means different compounds having same molecular formula. So it is known as isomerism. Okay, so different compounds having same molecular formula. Actually, there is a many classifications are there in organic chemistry, but here we are having those just introduction. Okay, so here we are writing example. So different compounds having same molecular formula. For example, you take ethyl alcohol. Okay, what is the formula of ethyl alcohol? Okay, we see the later. Next, similar we see other compound, that is dimethyl ether. Dimethyl ether. So both are totally different compounds. Like ethyl alcohol property ki diethyl property ki total different compounds. Okay, దాని ప్రాపర్టీస్ వేరే ఉంటాయి, దీని ప్రాపర్టీస్ వేరే ఉంటాయి. మ్యాక్సిమం 99% మ్యాక్సిమం అది వేరే కాంపౌండ్, ఇది వేరే కాంపౌండ్. బట్ ethyl alcohol formula is written as C2H5OH, but diethyl ether formula written as CH3OCH3. Here just arrangement is different. Now what is the final molecular formula? How many carbons? 2 carbons, 1 and 2. 2 carbons. How many hydrogens? 5 plus 1, 6. 3, 3, 6. 1 oxygen, 1 oxygen. Means ethyl alcohol can be shown by C2H6O, or dimethyl ether also shown by C2H6O. Both are having same molecular formula, but they belong to different compounds. So this is known as isomerism. So like this, many compounds are present. Okay, so many number of compounds are present. So now I give one more example. Okay, next write down. Okay, see the other example. Acetaldehyde. Okay, so next acetaldehyde. Next, so similar to this, there is one compound. So the formula of acetaldehyde is okay. Next, the similar formula is possessed by acetone, not acetone, ketone, acetaldehyde. Okay, see, so ఇక్కడ మనకి aldehydes కి ketones used అవ్వాలి, but 2-carbon aldehyde does not shows isomerism. Okay, alcohol okay గానే, but aldehydes కి minimum 3 carbons ఉండాలి. So we can write that is propanol. Okay, so propanol, the formula is CH3 CH2 CH4. This is known as propanol. Next, so one more compound is there, propanol. So its formula is CH3 CO CH3. Okay, now you see, so both are exactly different compounds. Propanol having aldehyde character, propanol ketone character. Okay, so here total groups are different. This is aldehyde, this is ketone group antam. Okay, just understand the example. How many carbons? 1 2 3. 1 2 3, 3 carbons. How many hydrogens? 3 4 5 6. 3 3 6. How many oxygens? 1 oxygen, 1 oxygen. So both can be written by using a single formula, but both are having total different properties. So the different compounds which are having same molecular formula are treated as isomers. That phenomenon is called isomerism. Okay. Okay, these are the properties of covalent compounds. Okay, so next in the next class we discuss the comparison between covalent bond and covalent properties and ionic properties. But it is must and should to write the notes. Okay, so no need to ask the others notes. Okay, because it may be there is a many mistakes will be there. You have the chance to take to see the video again and you write the notes yourself. Okay, don't depends on others. If there is a possibility is there, you have the video, just see the video again and try to write the notes. No need to ask the others, maybe they write some wrong. Okay.